Good morning. This is Dr. J. Mohan. I'm going to discuss about the signals and stochastic processing in the subject, the subheading of classification of signal, section 1. I am from EC department. This is a classification of signal. The signal can be classified in the nature of character in the time domain. It's going to classify for the two category. One is continuous time signal, another one is a discrete time signal. The continuous time signal, the signal that are defined for every instant of time are known as continuous time signal. The continuous time signal also called as analog signal. For the discrete time signal, the discrete instant of time are known as discrete time signal. The discrete time signal are continuous in amplitude but discrete in time. Based on these two category of signal of natural characteristics, we classified into 5 classification for both continuous as well as of discrete time signal. The first classification is discrete, deterministic and random signal. Second classification is periodic and non-periodic signal. Third classification is energy and power signal. Fourth classification is causal and non-causal signal. Fifth classification is even and odd signal. This section I am going to discuss about the deterministic and random signal and periodic and non-periodic signal, then energy and power signal. Next section I will discuss about the causal and non-causal signal and even and odd signal. First we go for the deterministic and random signal. Deterministic and random signal, how we classify. A signal exhibit no uncertainty of magnitude and phase at any given instant of time. This based on the magnitude and phase at any instant of time in the case, we consider as a deterministic signal can be completely represented by mathematical equation at any time is represented as a deterministic signal. For example, sinusoidal signal or cosine signal. So this signal we may represent by the mathematically. For here, x of t is equal to cos omega t. So the amplitude is represented as a 1. Here I have not mentioned amplitude is equal to 1. Cos omega t. Mathematically we may represent the signal. So this is represented as a deterministic signal. For non-deterministic signal or random signal, how we represent the signal character by uncertainty about the occurrence is called non-deterministic signal. A signal cannot be represented by the mathematical equation is called non-deterministic signal. We may different way we may represent for the deterministic as well as of non-deterministic signal. First case, the deterministic signal is a mathematically we can represent at any time. Non-deterministic signal we can't determine by the mathematical equation. For example of deterministic signal is cos signal. By example of non-deterministic signal is represented as a noise signal or random signal. So this is a case we represent as a deterministic as well as a non-deterministic signal. For the periodic and non-periodic signal, for the next case is represented as a periodic and non-periodic signal. This is a classification. How to represent for the periodic and non-periodic signal? A signal which has defined pattern and represent itself at a regular interval of time is called for the periodic signal. If not, the signal we call for the non-periodic signal. How to represent for the non-periodic signal? The signal which does not represent at a regular interval of time is called non-periodic signal or aperiodic signal. So here I am going to represent for the both continuous time periodic signal as well as a discrete time periodic signal in separate. For the first case, continuous time periodic signal. The continuous time periodic signal I represent for the x of t is said to be periodic if and only if x of t plus capital letter T is equal to t. So this t is represented as a periodic. If we change the period, that is the first periodic, second periodic, like third periodic, like that we represent. So that's why I may represent for the x of t plus capital letter T is equal to x of t. Then small letter t is present for the minus infinity plus motive. This kind of signal we call for the periodic signal, where capital letter t is a positive constant that represent the time period of periodic signal. The next case we go for the example how we represent for the periodic. The reciprocal of time period capital letter T of periodic signal is called frequency. The frequency f is equal to 1 by t. We may represent for the frequency f equal to 1 by t. Or angular frequency, how we represent the omega equal to 2 pi f. Based on this one, the time period we represent as a capital letter T is equal to 2 pi of f. For example of periodic signal, to see here, I take for the sinusoidal signal here. So up to 0 to 2 pi, 0 to 2 pi, what it will be going to happen, same it will be going to happen for the next 0 to 2 pi. This it will be continue. So that's why this is continuous time periodic signal. For here I take for the rectangular signal, that is rectangular star-teeth waveform. So 0 to t, what it will be going to happen for the signal, same it will be going to repeat it for the another 0 to, that is this is a second to t, and that is 0 to t. That's why this is t, this is a 2t. So this it will be continuously going to repeat it for continuously is going to repeat it. This kind of signal is represented as a continuous periodic signal. Next case, discrete time periodic signal. So how they going to represent for the discrete time signal as a discrete time signal x of n said to be periodic if it is satisfied the following condition. X of n is equal to x of n plus of capital letter N for all integer value of n. So where n is a time period of periodic signal and positive integer. This is we may represent for the angular frequency also. We represent for the angular frequency of discrete time signal is omega equal to 2 pi by capital letter N. Therefore, the time period of sequence capital letter N is equal to 2 pi by omega. So now here I take for the discrete time periodic signal as a cosine signal. This is I represent as a cos of, this is x of n is equal to, so amplitude 1 cos of n t. So this is the example of periodic discrete time periodic signal. So what the period, that is this n up to n is represented as a one period. This one it will be going to repeat it for continuously. So this kind of signal we represent as a discrete time periodic signal. Next we take for the same, that is a triangular signal for here. So 0 to n, what is going to happen for the your amplitude, same it will be going to repeat it for the next 2n, next 3n. So this will be continuously happen. This is called for the discrete time periodic signal. Next case, we go for the continuous time periodic signal. If a continuous time periodic signal does not have a definite pattern and does not repeat at the regular interval of the time, is known as a continuous time aperiodic signal. So what will be happen? So for example, you take for the continuous time aperiodic signal 0 to t, what is going to happen, that will be not repeated for here. So only 0 to t only is going to happen. This kind of signal we called for the continuous time aperiodic signal. So I will say one more time. If a continuous time signal does not have a defined pattern and does not repeat at the regular interval of the time, is known as a continuous aperiodic signal or non-periodic signal. For example, for here you take for the triangular signal, this triangular signal minus t to plus t, what will be going to happen? Not repeated for the next period. Here not repeated, only this period only is going to happen. This kind of signal is called for the continuous time aperiodic signal. Next case, discrete time aperiodic signal. If a condition of periodicity is not satisfied for the even for one value of n for discrete time signal of x of n, then the discrete time signal is aperiodic signal or non-periodic signal. This case I take for the triangular wave for here. So triangular wave of discrete time signal. So minus n to plus n, what they are going to have the character that will be not repeated for the next period. This kind of signal is represented as a discrete time aperiodic signal for all samples. Next, I am taking for the rectangular signal 0 to n. It's have the some amplitude character for each and every period, but it will be not repeated for the next period. So only this duration only the signal is going to happen. This kind of signal we call for the discrete time aperiodic signal. Next example, here I take for the some signal. We need to find for the periodic or not. At the same time, we need to find for the fundamental period also. So here I take signal as x of t equal to sine 10 pi t. So x of t is represented as this continuous time signal. Here I mention for the sinusoidal signal. Hence, it is periodic signal. How it's going to periodic signal? We find for the fundamental period. The fundamental period t is equal to 2 pi by omega. The omega here we mention for the 10 pi. You substitute for the 2 pi by 10 pi is equal to 1 by 5 second. Each and every 1 by 5 second, the sinusoidal signal is going to repeat it for together. For example, you take for here, this is the sinusoidal signal. This is a period is represented as a t. That is here. It's represented as a t. This value equal to 1 by 5 second. So this next 1 by 5 second, same sinusoidal signal will be going to repeat it. So this is another t, that will be second to t. What the character is present for here, same it will be going to repeat it for the next period also. This it will be continuously going to happen. This kind of signal is represented as a periodic signal. So the given signal, the x of t is equal to sine 10 pi t is a periodic signal. It's a fundamental period is equal to 2 pi by omega. Omega we received, that is omega equal to 10 pi. We substitute for the omega here, 2 pi by omega. Then each period is represented as 1 by pi. Each and every 1 by 5 second, the signal, sinusoidal signal is going to repeat it together. So the given signal is a periodic signal. Next, energy and power signal. So the signal said to be energy if and only if total energy is finite. I represent for the finite energy as a 0 less than E less than of infinity. 0 less than E less than of infinity. For an energy signal, the average power value is equal to 0. The non-periodic signal are the example of energy signal. So the energy signal, it's always present for the 0 less than of E less than of infinity. If the signal is energy, there is no power. The power value is equal to 0. For example, non-periodic signals, all non-periodic signals are the energy signal. Next, we go for the power signal. signal is said to be power signal if average power is equal to finite. I represent for the power is 0 less than p less than of infinitive. For power signal, the total energy value is equal to infinitive. The periodic signal is a best example of power signal. So here the energy signal is non-periodic signal or energy signal. The power signal is a periodic signal. If easily we can find out whether the signal is power or energy, what we are going to receive based on the mathematical equation of signals. So if the signal is, if you are going to find for the fundamental period of the signal, then the signal is represented as a power signal. If not getting the fundamental period, the signal is represented as an energy signal. At the same time, if energy is there in the signal, the power value is equal to 0. If the signal power is there, the energy value is equal to infinitive. This is a way we may represent as a energy as well as a power signal. Both energy and power signal we may classify for the two categories. One is based on the signal character, nature of the signal character. One is a discrete time signal, another one is a continuous time signal. We will see one by one. See, continuous time signal case. I take for the power. We need to find for the power. The average power or normalized power of continuous time signal. See, here I mentioned for the continuous. X of t is given by P is equal to limit t tends to infinity 1 by t integration of minus t by 2 to plus t by 2 mod of x of t square dt. The unit is represented as a watt. So the power signal already we discussed the power signal is represented as a periodic signal. See, the periodic signal interval I take for the minus t by 2 plus t by 2 of integration. So if the signal is periodic, then only is possible to find for the power or normalized power of continuous time signal or discrete time signal, both. Here we discuss about the continuous time signal. Next, we go for the energy. Here I mentioned for the total energy or normalized energy of the continuous time signal is defined as E is equal to limit t tends to infinity integration of minus t by 2 to plus t by 2 mod of x of t whole square dt. The unit is called for the joule. Next, we go for the discrete time signal cases. The discrete time signal case, I represent for the x of n. We represent for the x of n is represented as a discrete time signal. The total energy of the discrete time signal x of n is defined as E is equal to n equal to minus into plus into mod of x of t whole square. So sorry, this is x of n whole square. Then average power of discrete time signal x of t is defined as p is equal to limit n tends to infinity 1 by 2n plus 1 summation of minus n to plus n x of n. Here also mistake, x of n mod square. So this is represented as a discrete time case of energy as well as a power signal. Next, we go for some example. Determine the power and energy of the signal. X of t is equal to a sin omega 0 t plus phi. Here I take for continuous time signal. X of t is equal to a sin omega 0 t plus of pi. First, we go for the power. Power, the average power of the signal. We know the formula. P is equal to, in the continuous time signal, P is equal to limit t tends to infinity 1 by t integration of minus t by 2 to plus t by 2 mod of x of t square dt. Now, we receive the signal as a continuous time signal a sin omega 0 t pi. What the x place, you must substitute for this our continuous time signal, what we are received from the question. Now p is equal to t tends to infinity 1 by t integration of minus t by 2 to plus t by 2 a sin omega 0 t plus pi mod square of dt. For instead of x of t, we substituted for these values what we received for the signal. Then, so we know a sin a plus b formula, that is sin of a plus b. This is equal to 1 minus of cos a plus b divided by 2. That is, here is t, you can add for the t 1 by 2. So that formula I am utilizing for the trigonometric formula cases. So next step, p is equal to t tends to infinity, then a is there, this is mod square is there, then a is represented as a square, that is a constant, we take it out. Integration of minus t by 2 plus t by 2 1 minus of cos 2 omega 0 t plus 2 pi, this is 2, here I measure 2 divided by 2 dt. Then we may separate for all the cases. For the this is two cases are present for here. 1 minus of cos 2 omega 0 t plus 2 pi by 2. This is 1 by 2 I separated for here. There is limit t tends to infinity a square. This 2 I take it out for here t. Integration of minus t by 2 plus t by 2. Remaining is going to happen by the dt only is present. Minus of a square divided by 2t. Integration of minus t by 2 to plus t by 2 cos 2 omega 0 t plus 2 pi dt. Now this portion, see this portion is represent for the periodic nature, even though this is cosine term. If we make to integrate and substitute the limit is equal to 0. For next step is equal to 0. Remaining, what the remaining portion is that this portion only is going to act in. So that's why I write for the p is equal to lim t tends to infinity a square by 2t integration of minus t by 2 plus t by 2 dt. So then after make to integrate, the integration of dt is equal to t. You substitute for that minus t by 2 plus t by 2. Then I should write for that next step t limit t tends to infinity a square divided by 2t t by 2. Then this is minus is this is minus is represents a plus t by 2. Then the t by 2 plus t by 2 equal to t. So this t is getting, that will be a square by 2t into t by 2 t by 2t. These two are getting to cancel. Remaining what there is going to a square divided by 2. Finally the power is equal to a square. What the amplitude of here? This is amplitude of the, you are getting the signal, that is a, that is a square by 2. So a is represented as amplitude divided by 2 we got for the output. Now p is represented as a square by 2. Next we go for the normalized energy signal. The normalized energy signal is calculated from the minus infinity to plus infinity of integration x of t square dt is a formula for our continuous time signal energy, normalized energy value. Then we substitute for the x of t value, that is x of t is equal to a sin omega 0 t plus pi mod square of dt. Then we should follow for the same procedure where they are going to using for the power, we calculated for the power signal as sin a plus b, that is represented as 1 minus of cos 2a plus 2b divided by 2. Then that it will be going to adapt it to here. E is equal to a square integration of minus into plus into 1 minus of cos 2 omega 0 t plus 2 pi divided by 2 dt. Now we separated for the two cases. For here 1 by 2 is separate, here cos term is going to separate. We make it to for the integration is also made to separate. Then next step E is equal to a square divided by 2 integration of minus into plus into dt minus of a square by 2 integration of minus into plus into cos 2 omega t plus 2 pi dt. This term is entirely is represented as 0. If we make to do for the cos, substitute for the minus into plus into, that will be 0. That's why I kept for the 0 here. Only this portion is only I am doing for the integration. This step is represented as 0. Then E is equal to a square by 2. then dt is represented as a t minus infinity plus infinity. If you substitute for the t minus infinity plus infinity, what will be going to get? We get for infinity only. So that's why the signal E is equal to infinitive. Now, what is the condition for the power signal, power and the energy signal? If the power is there, in the signal x of t, then energy value is equal to infinitive. So then the energy value is equal to, this condition is going to satisfy. While we studied for the definition for here, if the signal is power, or if the signal is power signal, the energy value is equal to infinitive. If the signal is energy, the power value is equal to 0. This condition is going to satisfy for our given example. See, the energy value is equal to infinitive and the power value is represented as a square by 2. So the signal is power signal. It's not a energy signal. Next, we go for what the important point we learn from the power as well as of energy signal. First, both energy and the power signal are mutually exclusive. Why? Because of, if the signal is power, it's not a energy signal. If signal is a energy, it's not a power signal. For example, no signal can be both power signal as well as of energy signal. It's have only the energy or power. So that's a condition. If signal is energy, the power value is equal to 0. If signal is power, the energy value is equal to infinitive. So that's why I said both energy and power signal are mutually exclusive. There is no signal can be both power and energy signal. Second case, a signal is neither energy or power signal if both energy and power signal are equal to infinitive. So third case, all practical signal have finite energy, thus they are energy signal. If not, in the sense, it consists of power value is equal to 0. In practice, the physical generation of power signal is impossible since it is required infinite duration of infinite energy. So next point, all finite duration of signal of finite amplitude or energy signal. All finite duration signal of finite amplitude or energy signal. If the signal is finite, sure, the signal finite amplitude, the signal is energy signal. Next case, sum of the energy signal and the power signal is a power signal only. Sum of the energy signal and the power signal is only a power signal. Next point, a signal whose amplitude is constant over infinite duration is a power signal. The signal energy of the signal is not affected by time shifting and time invariant property of the signal. It is only affected by time scaling property. If the signal is energy, suppose you have received further some signal, if the signal is energy signal, is not affected by the time shifting property and time invariant property. Because of this time shifting and time invariant, both are is represented as a periodic nature. It is only affected by the time scaling property. These points are very, very important for based on the power as well as of energy in the continuous time signal as well as of discrete time signal. I will say this is first case. Both power and energy is mutually exclusive. If energy is there, there is no power. If the signal energy is there, there is no power. If power is there, there is no energy. We represent by the equal to infinity. Power value is equal to some constant E equal to infinity. Energy is present, the power value equal to 0. Next case, a signal is neither energy or power signal if both energy and power of the signal are equal to infinity. All practical signal have finite energy, thus they are energy signal. In practice, the physical generation of power signal is impossible since it is required infinite duration of the infinite energy. Next point, all finite duration signal of finite amplitude or energy signal. Sum of energy signal and power signal is a power signal only. A signal whose amplitude is constant over infinite duration is a power signal. The energy of the signal is not affected by time shifting and time invariant property of the signal. It is only affected by the time scaling property. For example, here I take for the one more example. Find of the following signal or energy signal or power signal, neither energy or nor power signal. I should take for 1 by 2 whole power n u of n. First we should find for the energy signal. Here previously we discussed about the continuous time signal. Now we can go for the discrete time signal. For the formula of energy in the discrete time signal, limit n tends to infinity, summation of n equal to minus capital letter n to plus capital letter n x of n whole square. So we received for the our x of n is equal to, this is x of n as a discrete time signal. We substitute for here x of n. Then limit n tends to infinity, n equal to minus into plus into 1 by 2 whole power n whole square u of n. We know u of n. What is that? U of n is equal to 1 when n greater than or equal to 0, 0 n lesser than value lesser than of infinity, or this is 0, that is represented n lesser than of infinity. So this is 0. This condition I may adapt it for the interval. So limit n tends to, that is equal to limit n tends to infinity, n equal to 0 to capital letter n. Here because of our formula is minus n to plus n. So that's why I write present for the n 1 by 2 whole power n. So n equal to 0 to infinity. This is 1 by 2 whole power n. This is equal to summation of n equal to 0 to capital letter n a power n. So this value is equal to 1 by 1 minus of a. So this formula I am going to adapt it here. 1 by 1 minus of what the a is there, 1 by 4. Right? That is 4 by 3. After simplification of this equation, 4 by 3 joule. Next we go for the power. Power of discrete time signal P is equal to n tends to infinity 1 by 2n plus 1, n equal to minus n to plus n, x of n mod square. We know x of n is equal to 1 by 2 whole power n u of n. So u of n is represented by the 0 to capital letter n. Then the power value P is equal to limit n tends to infinity 1 by 2n plus 1 summation of n equal to 0 to n 1 by 4 whole power n. So n tends to infinity 1 by 2n plus 1. For this case, I should write for, because of this is a power case. So I should write for the 1 minus of, as per the formula, 1 minus of 1 by 4 whole power n plus 1 divided by 1 minus of 1 by 4 as a power case. So this simplification, we substitute for this n equal to infinity, then we get for the 0. So the energy is a finite and power is 0. It satisfies for the condition. When the signal is energy, the power equal to 0. Then therefore x of n is a energy signal. So up to this much, I'm going to complete it for the first part of the classification of signal. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.